Let's have a journey of the universe with us, the unfolding of life. We belong to a dynamic unfolding universe that inspires wonder, awe, and creativity. Explore our offerings to understand what it means to be an integral part of the universe. This can energize your response to the ecological and social challenges of our times. Science has begun to weave together the historical story of a cosmos that emerged some 14 billion years ago. The vast complexity of this universe story is beginning to dawn on us. At the same time, we are becoming conscious of the growing environmental crisis and the rapid destruction of species and habitat. Waking up to our fundamental relationship with the cosmos will be a means of re-engagement with life as inherently valuable, thus to be cherished and fostered. The journey of the universe enables us to connect more deeply with the universe and the Earth of which we are a part. In doing this, we will appreciate the need for a vibrant human presence on the planet. Thus, the integrating story of the origin and development of the universe, of Earth, and of humans could become an inspiring vision for our time. This is because this story is giving us a sense of common evolutionary heritage and shared genetic lineage. This new understanding of kinship of humans with each other and with all life could establish the foundations for rediscovering our shared past so as to create a flourishing planetary community. The Big Bang was the moment 13.8 billion years ago when the universe began as a tiny, dense fireball that exploded. The Big Bang event is a physical theory that describes how the universe expanded from an initial state of high density and temperature. Various cosmological models of the Big Bang explain the evolution of the observable universe from the earliest known periods through its subsequent large-scale form. These models offer a comprehensive explanation for a broad range of observed phenomena, including the abundance of light elements, the cosmic microwave background, CMB, radiation, and large-scale structure. The overall uniformity of the universe, known as the flatness problem, is explained through cosmic inflation, a sudden and very rapid expansion of space during the earliest moments. However, physics currently lacks a widely accepted theory of quantum gravity that can successfully model the earliest conditions of the Big Bang. When the universe was very young, something like 1/100th of a billionth of a trillionth of a trillionth of a second, it underwent an incredible growth spurt. During this burst of expansion, which is known as inflation, the universe grew exponentially and doubled in size at least 90 times. Light chemical elements were created within the first 3 minutes of the universe's formation. As the universe expanded, temperatures cooled and protons and neutrons collided to make deuterium, which is an isotope of hydrogen. Much of this deuterium combined to make helium. For the first 380,000 years after the Big Bang, however, the intense heat from the universe's creation made it essentially too hot for light to shine. Atoms crashed together with enough force to break up into a dense, opaque plasma of protons, neutrons and electrons that scattered light like fog. About 15 million years after the Big Bang, the entire universe had cooled to the point where the electromagnetic radiation left over from its hot beginning was at about room temperature. In a 2013 paper, I labeled this phase as the habitable epoch of the early universe. If we had lived at that time, we wouldn't have needed the sun to keep us warm. That cosmic radiation background would have sufficed. Did life start that early? Probably not. The hot, dense conditions in the first 20 minutes after the Big Bang produced only hydrogen and helium along with a tiny trace of lithium, 1 in 10 billion atoms, and a negligible abundance of heavier elements. But life as we know it requires water and organic compounds, whose existence had to wait until the first stars fused hydrogen and helium into oxygen and carbon in their interiors about 50 million years later. The initial bottleneck for life was not a suitable temperature, as it is today, but rather the production of the essential elements. The universe has been expanding ever since the Big Bang. While the spatial size, if any, of the entire universe is unknown, it is possible to measure the size of the observable universe, which is approximately 93 billion light-years in diameter at the present day. Our solar system is estimated to have been born a little after 9 billion years after the Big Bang, making it about 4.6 billion years old. According to current estimates, the Sun is one of more than 100 billion stars in our Milky Way galaxy alone, and orbits roughly 25,000 light-years from the galactic core. Universe is the whole cosmic system of matter and energy of which Earth, and therefore the human race, is a part. Humanity has traveled a long road since societies imagined Earth, the Sun, and the Moon as the main objects of creation, with the rest of the universe being formed almost as an afterthought. Today it is known that Earth is only a small ball of rock in a space of unimaginable vastness, and that the birth of the solar system was probably only one event among many that occurred against the backdrop of an already mature universe. This humbling lesson has unveiled a remarkable fact, one that endows the minutest particle in the universe with a rich and noble heritage. Events that occurred in the first few minutes of the creation of the universe 13.7 billion years ago turn out to have had a profound influence on the birth, life, and death of galaxies, stars, and planets. Indeed, a line can be drawn from the forging of the matter of the universe in a primal, Big Bang, to the gathering on Earth of atoms versatile enough to serve as the basis of life. The intrinsic harmony of such a worldview has great philosophical and aesthetic appeal, and it may explain why public interest in the universe has always endured. Though the universe may seem a strange place, it is not a distant one. Wherever you are right now, outer space is only 62 miles, 100 kilometers, away. Day or night, whether you're indoors or outdoors, asleep, eating lunch or dozing off in class, outer space is just a few dozen miles above your head. It's below you too. About 8,000 miles, 12,800 kilometers, below your feet. On the opposite side of Earth, lurks the unforgiving vacuum and radiation of outer space. In fact, you're technically in space right now. Humans say, out in space, as if it's there and we're here, as if Earth is separate from the rest of the universe. But Earth is a planet, and it's in space and part of the universe just like the other planets. It just so happens that things live here and the environment near the surface of this particular planet is hospitable for life as we know it. Earth is a tiny, fragile exception in the cosmos. For humans and the other things living on our planet, practically the entire cosmos is a hostile and merciless environment. As the universe expanded, according to current scientific understanding, matter collected into clouds that began to condense and rotate, forming the forerunners of galaxies. Within galaxies, including our own Milky Way galaxy, changes in pressure caused gas and dust to form distinct clouds. In some of these clouds, where there was sufficient mass and the right forces, gravitational attraction caused the cloud to collapse. If the mass of material in the cloud was sufficiently compressed, nuclear reactions began and a star was born. The ages of the universe, our galaxy, the solar system, and Earth can be estimated using modern scientific methods. The age of the universe can be derived from the observed relationship between the velocities of and the distances separating the galaxies. The velocities of distant galaxies can be measured very accurately, but the measurement of distances is more uncertain. Over the past few decades, measurements of the Hubble expansion have led to estimated ages for the universe of between 7 billion and 20 billion years, with the most recent and best measurements within the range of 10 billion to 15 billion years. The observable universe is the region of space that humans can actually or theoretically observe with the aid of technology. It can be thought of as a bubble with Earth at its center. It is differentiated from the entirety of the universe, which is the whole cosmic system of matter and energy, including the human race. Unlike the observable universe, the universe is possibly infinite and without spatial edges.